Spring 1942, Eastern Front, somewhere near Kharkov. Soviet infantryman Dmitry Volkov crouched behind the rubble of what used to be a collective farm building, his Mosin Nagant rifle pointed at the German lines 200 meters away. The morning fog was lifting, revealing the muddy no-man's land between the opposing forces. Then he saw it. Something small, mechanical, crawling toward his position like a monstrous beetle. About 4 feet long, tracked like a miniature tank, moving with a steady mechanical precision that seemed almost alive. Behind it, trailing through the mud, 3 thin cables connected it to German operators hidden somewhere in the rubble across the field. Volkov had never seen anything like it. This thing, whatever it was, carried death in its steel belly. He raised his rifle, took aim at the approaching machine and squeezed the trigger. The bullets sparked off the vehicle's frontal armour. The little monster kept coming. More Soviet soldiers opened fire. Machine gun rounds stitched across the muddy ground, some finding their mark on the strange tracked vehicle. The thin side armour couldn't withstand the concentrated fire. The engine sputtered, smoke began pouring from the rear compartment, and the Goliath ground to a halt 15 meters from the Soviet trench. A German engineer somewhere in the ruins hit the detonation switch. The explosion that followed killed 3 Soviet soldiers and wounded 7 others. The crater left behind was 6 feet wide and 3 feet deep. The survivors would later describe it to their commissar as a German devil machine, a mechanical demon sent to kill them without risking German lives. They were witnessing the combat debut of one of World War II's most innovative and ultimately flawed weapons, the Goliath tracked mine, a device that represented the future of warfare wrapped in the technological limitations of its time. The story of the Goliath begins not in Germany, but in France. In late 1940, as German forces occupied France following their lightning victory, Wehrmacht engineers discovered something extraordinary near the Seine River. French engineer Adolphe Cagrès had been working on a prototype tracked demolition vehicle before the German invasion. The French prototype was crude, barely functional, but the concept was revolutionary. A small tracked vehicle that could deliver explosives to enemy positions by remote control, eliminating the need to risk engineers' lives in direct demolition operations. Wehrmacht ordnance officials examining the captured French prototype immediately recognized its potential. The concept aligned perfectly with German tactical doctrine, which emphasized technical innovation to achieve battlefield superiority. The problem with traditional demolition operations was simple and brutal. Combat engineers had to physically carry explosives to their targets, across open ground, under fire, with death statistics that made engineering units some of the most dangerous assignments in any army. The French prototype offered a solution. Remove the human from the equation, let a machine take the risks, let a disposable mechanical device absorb the enemy fire while delivering the explosive payload. In November 1940, Reich Marshal Hermann Göring's office issued specifications to the Carl F.W. Borgward Automotive Company in Bremen. The requirements were straightforward. Develop a remote-controlled tracked vehicle capable of carrying at least 50 kilograms of explosives to enemy positions. Make it small enough to present a minimal target. Make it controllable from a safe distance. Make it disposable. Borgward wasn't a tank manufacturer. They built civilian vehicles, trucks and passenger cars. But the company's engineers, led by Karl Borgward himself, saw the challenge as an opportunity. By early 1941, the first prototypes were being tested at proving grounds outside Bremen. The design that emerged was unlike anything seen before in military arsenals. Approximately 1.2 meters long, 60 centimeters wide, and just 30 centimeters tall. Tracks on either side, similar to those on full-size tanks but scaled down dramatically. The body was a simple steel box with minimal armour, 5 millimeters on the early models, barely enough to stop rifle bullets, certainly insufficient against anything heavier. The entire vehicle weighed 370 kilograms empty. With its 60-kilogram explosive charge, total weight was 430 kilograms. Light enough that 2 men could maneuver it on a specially designed 2-wheeled trailer. The control system was the real innovation. A joystick control box connected to the vehicle by a triple-strand cable, 650 meters long, wound on a drum inside the vehicle's rear compartment. As the Goliath moved forward, the cable played out behind it like a steel umbilical cord. 2 of the cable strands controlled movement and steering. operators could make the vehicle go forward, turn left or right by varying the power to each track, just like steering a full-size tank. The third strand served a single, final purpose: detonation. When the Goliath reached its target, the operator would trigger the explosive charge, destroying the vehicle along with whatever it had been driven into. The early SDKFZ 302 model used 2 Bosch electric motors, each producing 2.5 kilowatts. Total power output was modest, barely 6 horsepower, but sufficient to propel the small vehicle at speeds up to 10 kilometers per hour on flat terrain. Cross-country performance was significantly worse. The low ground clearance meant even modest obstacles could stop the vehicle cold. By spring 1942, the first production Goliaths were rolling off Borgwood's assembly line. Each one cost 3,000 Reichsmarks, an astronomical sum for a disposable weapon. For comparison, a Kar 98K rifle cost about 50 Reichsmarks. A single Goliath cost as much as 60 rifles. The German High Command accepted this expense because the potential tactical application seemed enormous. Imagine a weapon that could blow holes in enemy fortifications without risking combat engineers. Imagine a device that could be driven under enemy tanks, detonated, and destroy armor worth hundreds of thousands of Reichsmarks. Imagine being able to clear minefields without sending men to do it manually. The propaganda value alone seemed worth the investment. Germany would show the world that German engineering could create weapons the enemy couldn't even imagine. The Goliaths were assigned to specialized units. Panzer Pioneer companies, specifically designated as Goliath units, received the devices along with training on their operation and tactical deployment. The first units designated were Panzer Pioneer Companies 8111 through 815, assigned to the Special Army Pioneer Battalion ZBV 600, codenamed Typhoon or Typhoon. These units underwent intensive training on the Goliath's operation. The control system, while innovative, was not intuitive. Operators had to learn to steer the vehicle while watching it from a distance, often through smoke, dust, and battlefield chaos. The cable had to be carefully managed. If it snagged on obstacles, the Goliath would stop. If the cable was cut by enemy fire, shell fragments, or even by passing over sharp debris, the vehicle became inert, a 400-kilogram paperweight sitting on the battlefield with 60 kilograms of high explosive in its belly. The first combat deployment came in spring 1942 on the Eastern Front. German Army Group South was pushing toward the oil fields of the Caucasus. Soviet forces had established defensive positions that were proving costly to assault. Bunkers, trenches, minefields, all the nightmare obstacles that made frontal assaults into meat grinders. Panzer Pioneer Company 811 was attached to the 6th Army and ordered to use their Goliaths to clear path through Soviet defences. Lieutenant Hans Müller, commanding a Goliath platoon, later described the first combat use in a post-war interview. We rolled the Goliath off its trailer maybe 300 metres behind our lines. The operators set up the control box in a shell crater, good protection and good visibility toward the Soviet positions. We could see their trenches, maybe 200 metres away. The plan was simple: drive the Goliath across no man's land, into the Soviet trench system, detonate it, create a breach for our infantry to exploit. Simple in theory. The moment we sent the Goliath forward, the Soviets opened fire. They had never seen anything like it. At first they seemed confused. Then their machine guns opened up. Bullets were hitting all around it. Some rounds struck the vehicle. We could see sparks, but it kept moving. Slowly, about walking speed, but steady. The Soviets threw everything at it. Rifle fire, machine guns, even a 45mm anti-tank gun. A direct hit from the anti-tank gun would have destroyed it, but at 200 metres, shooting at a target less than 4 feet long and 1 foot tall, moving irregularly as we steered around obstacles, they couldn't get a clean shot. The Goliath made it to within 30 metres of the Soviet trench. Then a machine gun burst hit the left track, severing it. The vehicle slewed to a stop, one track spinning uselessly, the other destroyed. The operators tried to manoeuvre it forward on the remaining track, but it just spun in circles. We had to detonate it where it sat. Not ideal, but the explosion was impressive. The crater was substantial. We reported it as a success, but truthfully it hadn't achieved the objective. The breach wasn't usable. We'd used up one Goliath, cost 3,000 Reichsmarks, and accomplished nothing that a few artillery rounds couldn't have done better and cheaper. That first combat use revealed all the problems that would plague the Goliath throughout its operational life. The thin armour couldn't protect it from concentrated fire. The low ground clearance meant any obstacle larger than 11 centimetres could stop it. The electric motors, while quiet, lacked power for anything but gentle terrain. And most critically, the cable was vulnerable to everything: enemy fire, shell fragments, debris, even the Goliath's own tracks if the steering wasn't perfect. But there were successes, enough to keep the program funded, to keep the production lines running, to keep improving the design. In one documented case near Kharkov in May 1942, a Goliath was successfully driven into a Soviet command bunker. The 60-kilogram charge detonated inside the bunker's entrance, collapsing the structure and killing everyone inside, including a Soviet battalion commander. The entire assault cost Germany 1 Goliath and about 10 minutes of an operator's time. In traditional terms, taking that bunker would have required an infantry assault costing dozens of casualties. The Goliath took none. In June 1942, a Goliath cleared a path through a Soviet minefield, detonating multiple anti-tank mines as it crawled across the field. The explosion when the Goliath's charge was triggered created a clear lane for German armour to advance. Again, minimal German casualties for a task that traditionally cost engineers lives. But for every success, there were 5 failures: Goliaths that got stuck in mud, Goliaths whose cables were cut before reaching their targets, Goliaths destroyed by enemy fire before closing with their objectives. The operational success rate was dismally low, perhaps 20% at best. Soviet forces quickly learned countermeasures. When a Goliath was spotted, the standing order was simple: shoot the cable. One burst from a machine gun, properly aimed behind the vehicle rather than at it, would sever the thin cables and render the Goliath inoperable. Soviet infantrymen would even leave their trenches under covering fire to cut Goliath cables with entrenching tools. The risk of being shot while running across open ground to disable a Goliath was apparently preferable to letting it reach the trench and detonate. By late 1942, German engineers recognized that the electric-powered SDKFC-302 had fundamental problems beyond its tactical vulnerabilities. The electric motors were expensive to manufacture. They were difficult to maintain in field conditions. The batteries required charging, which meant Goliath units needed access to power generation equipment that was often unavailable at forward positions. Most problematically, the electric motors lacked the power needed for anything but the flattest terrain. In October 1942, Borgward received orders to develop an improved version using an internal combustion engine. Zündap, a company that manufactured motorcycles, was brought into the program. They provided a 2-stroke, 2-cylinder gasoline engine originally designed for motorcycle use. 700 cubic centimetres, air-cooled, producing 12.5 horsepower. Twice the power of the electric motors, easier to maintain, using fuel that was readily available at any frontline position. The new model, designated SDKFZ-303, entered production in April 1943. It was heavier at 430 kilograms empty and carried a larger explosive charge, 100 kilograms instead of 60. The increased power from the gasoline engine compensated for the extra weight. Top speed remained about 10 kilometers per hour, but the 303 could maintain that speed across rougher terrain that would have stopped the electric model. The operational range increased as well, up to nearly 12 kilometers on roads, though cross-country range remained limited. The 303 had another advantage. The gasoline engine was loud. This might seem like a disadvantage, but it actually helped in some tactical situations. The noise announced the Goliath's approach, which created psychological effects that German commanders quickly learned to exploit. Enemy troops hearing the distinctive buzz of the 2-stroke engine would often panic, abandoning positions even before the Goliath arrived. The sound became associated with imminent death, with demolition and destruction, with the relentless advance of German technology. Soviet soldiers began calling the Goliath by various names: the Beetle, the Bug, the Crawling Bomb. German propaganda seized on this, playing up the Goliath as a wonder weapon, unstoppable, inevitable. The reality, as frontline troops knew, was far less impressive. But perception matters in war, and the psychological impact of the Goliath often exceeded its actual tactical effectiveness. The true test of the Goliath came in July 1943 at the Battle of Kursk, the largest armoured engagement in history. The Germans launched Operation Citadel, an offensive aimed at eliminating the Soviet salient around Kursk. Soviet forces, knowing the attack was coming, prepared defensive positions of unprecedented depth and complexity. Multiple defensive lines, each protected by extensive minefields. The statistics of Soviet defensive preparations at Kursk are staggering. By July 1943, Soviet engineers had laid approximately 503,000 anti-tank mines and 439,000 anti-personnel mines across the Kursk salient. The density in some sectors exceeded 2,500 mines per kilometre of front. Traditional mine-clearing methods would be suicidal and impossibly slow. German planners turned to their specialised units, including the Goliath companies. Panzer Pioneer Company 312, equipped with the newer gasoline-powered Goliaths, was attached to the 654th Heavy Panzerjäger Battalion, which operated the massive Ferdinand tank destroyers. These 65-ton behemoths mounted an 88mm gun that could destroy any Soviet tank at range, but they lacked machine guns for close defence and were vulnerable to infantry attack. More immediately, they couldn't cross minefields without engineer support. The plan called for Goliaths to be sent ahead of the Ferdinands, crawling across the minefields, detonating mines as they went. When the Goliath reached the far edge of the minefield, or when it had triggered enough mines to be damaged, the operators would detonate its main charge, hopefully clearing additional mines in the explosion. In theory, this would create lanes through which the Ferdinands could advance with reduced risk. In practice, the execution was more complicated. On July 5, 1943, the first day of Operation Citadel, Goliaths were deployed in the northern pincer of the German offensive. Oberfeldwebel Ernst Hartmann, a Goliath operator with Company 312, later described the experience. The minefield stretched as far as we could see. The Soviets had marked it with white tape and warning signs, which seemed almost polite until you realised it meant they were confident we couldn't cross it anyway. We set up our control stations in shell craters about 500 metres back. We could barely see the far side of the minefield through the morning mist. Each operator had one Goliath. We were to go in sequence. I was third. The first Goliath moved out at 04:45 hours. We could hear its engine even at 500 metres, that distinctive two-stroke buzz. It crawled forward, trailing its cables, moving maybe as fast as a man walks. Within 50 metres it hit the first mine. We saw the explosion, but the Goliath kept moving. The mines were anti-tank mines, powerful enough to destroy a tank track, but the Goliath was so light, weighing less than 500 kilograms, that many anti-tank mines wouldn't trigger from its weight. The Soviets had anticipated this. Mixed in with the anti-tank mines were anti-personnel mines, smaller, more sensitive. These would trigger from the Goliath's weight. At 75 metres, the first Goliath hit an anti-personnel mine. The explosion was smaller, but it severed the left track. The vehicle slewed to a halt. The operator detonated the main charge. The explosion was substantial, probably cleared a radius of maybe 5 metres, certainly destroyed several more mines in the blast. But that was one Goliath to clear a path maybe 10 metres deep into a minefield that extended 300 metres. The second Goliath went out at 500. It made it 90 metres before losing a track. Same result. Detonate in place. Clear a small area, nowhere near enough. My turn came at 5:15. I sent my Goliath forward, trying to steer between the craters left by the first two. The theory was that if they'd triggered mines, that area should be clear. But the minefield wasn't uniform. I made it maybe 100 metres. Then I heard the bang over the engine noise, saw the Goliath jerk to a stop. Track severed. I hit the detonator. That was 3 Goliaths, 9,000 Reichsmarks of equipment, to clear maybe 30 metres of a 300-metre minefield. Not effective, not remotely cost-effective. Despite this limited success, there were areas where Goliaths performed better. Some units used them not for mine clearing but for attacking fortified positions. A Goliath loaded with 100 kilograms of high explosive, driven into a bunker or pillbox and detonated, could be devastatingly effective. The confined space amplified the blast effect. Bunkers that could withstand artillery fire might collapse from a Goliath explosion triggered inside or immediately adjacent to the structure. At Kursk, several Soviet strongpoints were eliminated by Goliaths where conventional assault would have been prohibitively expensive in casualties. But these successes were localized, individual tactical wins that didn't change the strategic outcome. The Battle of Kursk ended in German defeat. The Goliath, despite its innovative design, hadn't been the game-changer German planners hoped for. After Kursk, Goliath employment patterns changed. Rather than using them in massed operations, German commanders increasingly deployed them in small numbers for specific targets. Urban combat, particularly, seemed suited to Goliath operations. The confined streets and rubble-choked environments of city fighting created situations where the Goliath's small size and remote operation offered genuine advantages. This would be tested most dramatically in Warsaw in 1944, during the uprising that would become one of the war's most brutal urban battles. On August 1, 1944, the Polish Home Army launched an uprising against German occupation of Warsaw. The timing was meant to coincide with the Soviet advance, allowing Polish forces to liberate their own capital before the Soviets arrived. The Germans responded with overwhelming force and absolute ruthlessness. SS units flooded into Warsaw with orders to crush the uprising completely. The fighting devolved into house-to-house, room-to-room combat. Into this nightmare, the Germans deployed Goliaths. Several Panzer Pioneer companies with Goliaths were assigned to the forces suppressing the uprising. The tactical situation seemed ideal for Goliath employment. Polish resistance forces had erected barricades throughout the city, blocking streets and creating strongpoints. These barricades, built from rubble, furniture, cobblestones, anything available, were difficult to reduce with conventional weapons. Artillery could blast at them, but in the confined urban environment, artillery fire risked German casualties from debris and uncontrolled fires. Direct assault by infantry was costly. The Poles, fighting for their survival and their city, defended with desperate courage. The Goliath offered a solution. Drive the device up to a barricade, detonate the 100-kilogram charge, blow a gap in the barricade, send troops through. In theory, this would minimize German casualties while systematically reducing Polish defensive positions. The reality was more complex. Polish Home Army fighters, many of them veterans of the 1939 campaign or partisan operations, quickly identified the Goliath's vulnerability. The cables. Orders went out through the Polish command structure. When you spot a Goliath, shoot the cables or cut them. Volunteers, knowing they faced near certain death, would deliberately expose themselves to German fire to reach Goliath cables and sever them with axes, knives, even bare hands pulling at the thin strands until they broke. One documented incident from August 5, 1944, involved a Polish fighter named Tadeusz Zawadzki, known by his nom de guerre Zośka. His unit was defending a barricade on Okopowa Street when a Goliath appeared, crawling toward their position with that distinctive mechanical persistence. Zośka crawled out from behind the barricade under covering fire from his comrades, dragging himself across rubble and broken pavement while German machine guns chewed up the street around him. He reached the Goliath's cables just as the vehicle was 20 meters from the barricade. With a combat knife, he sawed through the cables. The Goliath ground to a halt. Zośka rolled back behind the barricade seconds before the German operator, either in frustration or following standing orders, triggered the detonation. The explosion killed 3 German soldiers who had been moving up behind the Goliath in preparation for exploiting the breach it was supposed to create. Zośka survived the Warsaw Uprising, only to be killed in September 1944 during a different action. But his successful disabling of the Goliath became one of many examples of Polish ingenuity and courage in countering German technological advantages. The Germans tried to counter these tactics. They provided covering fire for Goliaths, machine guns and rifles, aimed at suppressing enemy troops who might try to reach the cables. They deployed Goliaths at night, hoping darkness would make cable cutting more difficult. They even experimented with dummy cables, hoping to confuse defenders about which cables to cut, though this added complexity that frontline operators couldn't maintain. None of it was particularly effective. The fundamental vulnerability remained. A weapon dependent on a physical tether could be defeated by cutting that tether. By late August 1944, after weeks of brutal combat, the Germans had lost numerous Goliaths in Warsaw, many destroyed by having their cables cut, others damaged by the explosion of Polish improvised explosives, some simply stuck in rubble, unable to navigate the chaotic urban terrain, abandoned and eventually captured by Polish forces. The Polish fighters who captured intact Goliaths did something the Germans hadn't anticipated. They stripped them down, removed the explosive charges and repurposed those explosives for their own use. Polish combat engineers had chronic shortages of explosives. The 100 kilograms of high-grade military explosive in each captured Goliath was treasure. Multiple documented cases exist of Polish Home Army engineers using explosives from captured Goliaths, to demolish German-held buildings or create their own improvised mines against German armour. After the war, in 1946, Soviet forces occupying Warsaw discovered numerous stripped Goliath hulks scattered around the city. Many had been captured by the Poles, disassembled for parts and explosives, the empty shells left wherever they had been worked on. Soviet engineers, perhaps wanting to clean up or perhaps just following orders, collected these hulks and buried them in a pit outside the city. Decades later, recovery operations would find these burial sites, and pieces of Goliaths from the Warsaw Uprising would end up in museums and private collections, silent testimony to one of the weapon's most significant deployments and one of its most comprehensive failures. But the tactical pattern established at Warsaw, the ease with which determined defenders could neutralize Goliaths, became known throughout Allied forces. When Goliaths appeared on other fronts, Allied troops knew what to do: shoot the cables. D-Day, June 6, 1944. The largest amphibious invasion in history, Allied forces landing on 5 beaches across Normandy. German defences, prepared over years, included every weapon system the Wehrmacht possessed, including Goliaths. Several Goliath units were stationed along the Atlantic Wall. German planners envisioned using them against landing craft, against troops massed on beaches, against the armour that would inevitably follow the initial assault. Goliaths positioned in concrete bunkers, ready to be rolled out onto the beaches, driven into concentrations of Allied troops or vehicles, detonated to create casualties and chaos. The reality of D-Day made such tactical employment nearly impossible. The sheer violence of the naval bombardment preceding the landings destroyed many German defensive positions before they could be manned. Communication systems were shattered. Command and control broke down. Individual strongpoints found themselves isolated, unable to coordinate with neighbouring positions, fighting blind against an enemy whose numbers seemed infinite. At Utah Beach, German positions included several Goliaths. The naval bombardment was so intense that most were destroyed before the first landing craft touched sand. One Goliath did survive intact. A German Oberfeldwebel, his bunker still standing despite taking multiple shell hits, attempted to deploy his Goliath against American troops advancing from the beach. He rolled the device off its trailer, started the engine, pointed it toward a concentration of American soldiers perhaps 100 meters away. The control cables played out as the Goliath crawled forward. Then a 5-inch shell from a destroyer offshore landed 30 meters from the bunker. The blast severed all 3 cables instantly. The Goliath, suddenly inert, sat motionless on the beach. American troops approaching saw it, recognized it from intelligence briefings, gave it a wide berth until engineers could examine it. Within an hour, the Goliath was in American hands, the explosive charge removed, the vehicle itself hauled away for technical intelligence analysis. Photographs from D-Day and the days following show multiple images of Allied soldiers examining captured Goliaths. The small tracked vehicles seem almost toy-like in these photos, especially compared to the massive scale of the invasion force surrounding them. British soldiers on Gold Beach posed with captured Goliaths, grinning for cameras, the deadly weapons reduced to curiosities, trophies of victory. The psychological impact worked in reverse. Where German propaganda had intended the Goliath to terrify and intimidate, Allied troops finding captured examples treated them almost as jokes. Look at this crazy thing the Germans built. A robot tank loaded with explosives. Did they really think this would stop us? The casual mockery wasn't entirely fair. A Goliath detonating among troops on an open beach could cause horrific casualties. But the tactical employment was so difficult, the weapon so vulnerable, that the theoretical threat never materialized into practical danger. At Omaha Beach, the bloodiest of the D-Day landings, not a single Goliath successfully engaged Allied forces. Several were found in German positions after the fighting, most destroyed by the naval bombardment. 1 or 2 knocked out by German demolition teams during the retreat to prevent their capture intact. The Atlantic Wall, the vaunted German defensive system meant to throw any invasion back into the sea, had included Goliaths as part of its arsenal. Their complete tactical failure on D-Day underscored the fundamental problems with the weapon system. Too fragile, too easily countered, too dependent on conditions that never existed in the chaos of actual combat. But there was one theatre where the Goliath achieved a degree of success, one incident where the weapon functioned more or less as designed and inflicted significant casualties on Allied forces: southern France, August 1944. Operation Dragoon, the Allied invasion of southern France. The 509th Parachute Infantry Battalion, an American airborne unit, was operating in the Maritime Alps, mountainous terrain that offered excellent defensive positions for German forces attempting to delay the Allied advance. On August 18, 1944, a patrol from the 509th encountered a German defensive position blocking a mountain road. The Americans had vehicles, trucks, and a few armoured cars moving up the road to support infantry operations. The Germans, a small unit from a Panzer Pioneer Company, had prepared an ambush that included a Goliath. They waited until an American armoured car was in the ideal position, exposed on the road with limited room to manoeuvre. Then they launched the Goliath. The device crawled forward from concealment, moving faster than expected on the smooth road surface, engine screaming that distinctive two-stroke wail. American troops saw it, opened fire, but in the confusion and at close range, in terrain where the vehicle was partly shielded by rocks and roadside vegetation, they couldn't stop it. The Goliath reached the armoured car. The German operator triggered the detonation. The 100 kilograms of high explosive destroyed the armoured car completely, killed its 3-man crew instantly, and wounded 7 American paratroopers nearby with fragments and blast effects. It was one of the Goliath's most successful single engagements of the entire war. 1 vehicle, 1 operator, 3 American soldiers killed, 7 wounded, 1 vehicle destroyed. By conventional military calculus, a significant tactical success. The cost was 1 Goliath at perhaps 1,000 Reichsmarks by late 1944, after economies in production had reduced the unit price. But this single success, documented in American unit reports and later German records, stood out precisely because it was so unusual. For every successful Goliath engagement like this one, there were dozens where the weapon failed to achieve anything. American forces in the Maritime Alps, shaken by this incident, issued immediate orders about Goliath countermeasures. When one is spotted, concentrate fire on the cables and the vehicle itself. Use any weapon available. Don't let it close. Within days, another Goliath was spotted by American paratroopers. This time they were ready. Concentrated rifle and machine gun fire destroyed the Goliath before it closed to within 50 meters. The cables were cut, the engine was smashed, and the vehicle sat immobile until American engineers could reach it, remove the explosive charge, and haul the hulk away for analysis. The pattern established in Warsaw, on Normandy's beaches, and in the French mountains repeated across every front. The Goliath could be effective under ideal conditions, against unprepared enemies, with proper tactical support. But those conditions rarely existed. Combat was chaotic, unpredictable. The Goliath's vulnerabilities outweighed its potential advantages in nearly every real-world scenario. By late 1944, German use of Goliaths dropped off dramatically. Production continued through January 1945, but deployment to frontline units became sporadic. The reasons were manifold. German industry was collapsing under Allied bombing. Raw materials were scarce. The factories producing Goliaths could have been making more critical weapons. The specialized Panzer Pioneer companies that operated Goliaths had suffered heavy casualties. Trained operators were dead, captured or reassigned to more conventional engineering duties that the desperate German situation demanded. And perhaps most significantly, frontline commanders had largely lost faith in the weapon. After 3 years of combat use, the pattern was clear. The Goliath was a fascinating technical achievement, an innovative concept, a glimpse of future warfare. But as a practical weapon in 1944, it was a failure. The final production statistics tell the story. Between 1942 and 1945, Germany produced 7,564 Goliaths. Of these, approximately 2,650 were the Electric's DFZ 302 model, built between April 1942 and January 1944. The remaining roughly 4,900 were gasoline-powered SKF Z303 variants, produced between April 1943 and January 1945. 7,564 disposable demolition vehicles. At an average cost, after production efficiencies reduced prices from the initial 3,000 Reichsmarks to perhaps 1,000 Reichsmarks for late war models, the total program cost Germany approximately 10 million Reichsmarks. For comparison, Germany produced approximately 25,000 Panzer IV tanks during the war. Each Panzer IV cost about 103,000 Reichsmarks. 7 Goliaths cost roughly what 1 Panzer IV cost, but a Panzer IV could be used repeatedly, could fight multiple engagements, could be repaired and returned to service. A Goliath destroyed itself in its single use. The cost-benefit analysis viewed in hindsight seems insane. But in 1940, when the program began, the potential seemed worth the investment. A weapon that could eliminate enemy fortifications without risking German lives. A device that could clear minefields mechanically, rather than with combat engineers crawling across deadly ground. The vision was compelling. The execution was flawed by technological limitations that 1940s engineering couldn't overcome. The cable was the fundamental problem. A wireless control system would have solved many of the Goliath's vulnerabilities, but reliable radio control technology didn't exist in forms small and robust enough for battlefield use. German engineers experimented with radio-controlled versions. Prototypes existed. But radio systems of the era were too bulky, too expensive, too prone to jamming or interference. The cable, for all its vulnerabilities, remained the only practical solution. Post-war analysis by Allied engineers who examined captured Goliaths reached mixed conclusions. The American Technical Intelligence reports noted that the concept was sound. A small, tracked, remotely operated demolition vehicle had genuine military applications. The execution had problems, but those were engineering challenges that better technology could overcome. The fundamental idea was valid. British reports were more dismissive. They noted the Goliath's poor combat record and concluded that the weapon represented wasted German industrial capacity. Resources spent on Goliaths could have produced more tanks, more artillery, more weapons with proven effectiveness. Soviet evaluations were interesting. Soviet engineers captured numerous Goliaths on the Eastern Front. They studied them carefully, looking for concepts worth incorporating into Soviet weapons development. The Soviets concluded that the Goliath itself was flawed, but the principle of remote-controlled weapons systems deserved continued research. In the decades after World War II, as technology advanced, the concept the Goliath represented evolved into more effective systems. Radio-controlled demolition vehicles became practical as radio technology improved. Precision-guided munitions eliminated the need for a tracked vehicle to deliver explosives to a target. Drones, both aerial and ground-based, inherited the Goliath's mission of delivering ordnance without risking human operators. Modern bomb disposal robots, used by military and police forces worldwide, are direct descendants of the Goliath concept. Remote operation, tracks for mobility, a camera system, something the Goliath lacked, allowing the operator to see from the robot's perspective. These modern devices perform missions that would have been impossible for Goliath operators who had to maintain line of sight to their vehicles. The current use of small drones for reconnaissance, for targeting, even for dropping explosives on enemy positions, all echo the Goliath's mission. Remove the human from the immediate danger. Use a machine, ideally a disposable or at least recoverable machine, to accomplish tasks that would otherwise require risking soldiers' lives. In museums today, preserved Goliaths sit in exhibits on World War II technology. They look almost comical, small, boxy, with their prominent tracks and minimal armor. Museum placards explain their function, note their limited success, mention their high production numbers despite poor combat effectiveness. But they rarely capture the psychological reality of encountering a Goliath in combat. The soldiers who saw these devices crawling toward them, who heard the buzz of the two-stroke engine or the whine of electric motors, who knew that 60 or 100 kilograms of high explosive was approaching with mechanical inevitability, experienced something different from what museum visitors see. For those soldiers, the Goliath represented the terrifying potential of mechanized warfare, a weapon without fear, without hesitation, that would crawl toward you with absolute commitment until it reached you and exploded, or until you managed to stop it. The fact that Allied soldiers learned to counter Goliaths effectively doesn't erase the psychological impact of facing them. There's a peculiar footnote to the Goliath story that emerged decades after the war. In the 1960s, a French farmer ploughing his field in Normandy struck something buried in the soil. Investigation revealed it was a Goliath, buried in 1944, presumably to hide it from approaching Allied forces. French army bomb disposal experts were called. They carefully excavated the device. It was a gasoline-powered SDKFZ-303, remarkably well preserved after 20 years underground. The rubber tracks had rotted away, but the metal components were intact. Most critically, the 100 kilograms of high explosive remained live. The detonator had not been connected, suggesting the Goliath had never been fully armed. The disposal team transported it to a controlled area and safely destroyed the explosives. The Goliath chassis was preserved and eventually donated to a local museum. Similar discoveries continued through the 1970s and 1980s. Unexploded Goliaths turning up in construction sites, in fields, in forests where battles had been fought decades earlier. Each one represented a potential hazard. The explosives, if properly stored, could remain dangerous for decades. Disposal teams across Europe dealt with dozens of Goliaths found long after the war ended. Some were preserved for museums. Most were destroyed as the safest option. It's likely that more remain buried, their locations forgotten, waiting for some future excavation to uncover them. The German soldiers who operated Goliaths had mixed feelings about the weapons. Some appreciated the theoretical advantage of being able to attack enemy positions without exposing themselves. Others saw the Goliath as symptomatic of Germany's declining military situation, a gimmick weapon that consumed resources without delivering proportional results, a sign that Germany was losing the war and grasping at technical solutions to problems that required more fundamental military capabilities. There's a post-war account from a former Goliath operator speaking to a historian in the 1970s, name withheld, that captures this ambivalence. We called it the beetle, sometimes affectionately, sometimes with contempt. It depended on the day, depended on whether it had worked or failed. When you sent one out and it actually reached its target and detonated, and you saw the explosion and the damage, there was satisfaction. You'd accomplished the mission without risking men. That was the promise of the Goliath, but most times it didn't work. The cable would snag, the enemy would cut it, the device would get stuck or damaged or just fail mechanically. And you'd wasted the weapon, wasted the time, wasted the opportunity. We joked that the Goliath was like Germany itself by 1944. Clever engineering, impressive on paper, fundamentally unable to accomplish what was needed. That might not be fair to the engineers who designed it. They did their best with the technology available, but for those of us trying to use it in combat, it was frustrating. You wanted it to work. Sometimes it did, usually it didn't. That quotation, if authentic, summarizes the Goliath experience. A weapon with genuine potential, limited by the technological constraints of its era and the tactical realities of modern warfare. The idea of a remote-controlled, explosive delivery system was decades ahead of its time. The execution was handicapped by 1940s technology. The cable control system, the only practical option at the time, was also the weapon's greatest vulnerability. Without that vulnerability, the Goliath might have been a true game-changer. With it, the device remained an interesting experiment that consumed resources without delivering proportional results. The Germans tried. They produced over 7,500 units. They deployed them across multiple theatres. They continuously refined the design, from electric to gasoline power, improving the armour, increasing the explosive payload, but they couldn't overcome the fundamental problems, and so the Goliath remains a historical footnote, a might-have-been weapon, a glimpse of future warfare trapped in the technological limitations of World War II. Today, when military historians discuss innovative weapons of World War II, the Goliath usually appears as a curiosity. The assault rifles, the jet fighters, the rockets, those technologies that successfully transitioned from experimental to standard weapons. Those are the main stories. The Goliath is the supporting character, the weapon that didn't quite work but showed the direction technology would eventually take. Perhaps that's the right perspective. Not every innovation succeeds in its initial form. Not every clever idea translates to battlefield effectiveness. The Goliath tracked mine was innovative, fascinating, ingenious in concept. In practice, it was a limited success weapon that consumed resources without achieving its promise, but it pointed toward the future. Decades later, when engineers developed practical remote-controlled weapons, when drones became ubiquitous tools of warfare, when precision-guided munitions eliminated the need for a vehicle to deliver explosives, those technologies inherited the mission the Goliath attempted. Remove humans from immediate danger, use machines to accomplish tasks that would otherwise require risking lives. Deliver explosives to targets with precision and minimal operator risk. The Goliath failed at this mission, but the mission itself was valid. The future would prove that. Spring 1942, Eastern Front. Soviet infantryman Dmitry Volkov, the soldier who first encountered a Goliath in combat, survived the war. In the 1960s, he was interviewed by a Soviet military historian researching German weapons. He was asked what he remembered about the German crawling bomb. Volkov's response: "It was terrifying until we realized we could stop it. Then it was just another German weapon that looked impressive but didn't work. That's the story of the Goliath tracked mine. Terrifying until understood, impressive until examined, innovative but ultimately ineffective. A weapon that promised much, delivered little, and pointed toward a future it couldn't reach with 1940s technology. 7,564 units produced, countless millions of Reichsmarks spent, and after all that effort, all that engineering, all that production, the Goliath tracked mine's greatest contribution to military history might simply be this: it showed what was possible, and it showed why it wasn't possible yet. The lessons learned from the Goliath program influenced post-war military development in ways that weren't immediately obvious. When the United States Army examined captured Goliaths in detail at the Aberdeen Proving Ground in Maryland, engineers spent months testing the vehicles under various conditions. They drove them across different terrain types, measured their performance characteristics, analysed their control systems, and most importantly, studied why they failed so often in combat. The Aberdeen tests, conducted between late 1944 and mid-1945, produced a comprehensive technical report that would influence American thinking about remote-controlled weapons for decades. The report's conclusions were nuanced. The Goliath concept was tactically sound for specific applications. The execution suffered from multiple engineering compromises forced by wartime production constraints and technological limitations. Most significantly, the cable control system, while reliable when protected, was too vulnerable for general combat use. The report recommended continued research into radio-controlled alternatives. This recommendation led directly to post-war American development of remote-controlled vehicles. In the 1950s, the United States Army experimented with radio-controlled demolition vehicles, based partly on lessons from studying the Goliath. These American vehicles were larger, more robust, and used radio control instead of cables. But they faced their own problems. Early radio control systems were bulky, consumed significant power, and were vulnerable to interference and jamming. The technology wasn't mature enough for reliable battlefield use. It would take another 3 decades before electronics miniaturization and improved radio systems made truly practical remote-controlled military vehicles possible. By the 1980s, when American forces developed the first practical bomb disposal robots, the technology had finally caught up to the mission the Goliath had attempted 40 years earlier. The Soviet Union's approach to the Goliath's lessons was different. Soviet engineers, examining captured examples, focused less on the remote control aspect and more on the concept of expendable weapon systems. This aligned with Soviet military doctrine, which accepted higher material losses in exchange for tactical gains. In the immediate post-war years, Soviet designers experimented with various expendable weapon concepts, including teletanks, radio-controlled tanks loaded with explosives. These experiments continued sporadically through the 1950s, but never resulted in widespread deployment. The Soviets concluded, as the Germans had, that the technological limitations of the era made such weapons impractical despite their theoretical advantages. But the research continued in Soviet military institutes, and some historians argue that this early work influenced later Soviet development of remote-controlled systems for nuclear, biological, and chemical warfare scenarios, where protecting human operators was paramount. Britain's evaluation of the Goliath was characteristically pragmatic. British engineers at the Royal Armament Research and Development Establishment examined several captured examples and concluded that while ingenious, the Goliath represented an inefficient allocation of industrial resources. British doctrine emphasised weapons that could be used repeatedly, maintained in field conditions, and operated by troops with minimal specialised training. The Goliath failed on all 3 criteria. It was single-use, required careful handling, and needed trained operators. British post-war development focused instead on improved conventional demolition techniques and man-portable explosive systems that gave similar results with greater reliability and lower cost. The British approach was to make human engineers more effective rather than trying to replace them with machines. This philosophy would dominate British military thinking until the electronics revolution of the late 20th century made remote systems genuinely practical. France, having had the original concept stolen by the Germans, developed its own post-war interest in remote-controlled demolition systems. French military archives reveal that in the late 1940s, French engineers attempted to recreate and improve upon the original Kegres design that had inspired the German Goliath. These French post-war experiments used more powerful engines and attempted to incorporate early radio control technology. Several prototypes were built and tested between 1948 and 1952. The French devices were larger than the German Goliath, about twice the size, with correspondingly larger explosive payloads. But they encountered the same fundamental problems. Radio control systems weren't reliable enough, and cable control was too vulnerable. The French program was quietly cancelled in 1953, another victim of technology that couldn't yet match the vision. The prototypes were stored in military warehouses and eventually scrapped. Only photographs and technical documents remain, showing yet another attempt to make the Goliath concept work with technology that wasn't quite ready. One of the more interesting footnotes to the Goliath story involves its influence on civilian technology. In the 1960s, as commercial television became widespread, engineers developing remote-controlled cameras for dangerous environments, like nuclear facilities and deep-sea exploration, drew on research originally conducted for military remote-controlled vehicles. The tracking systems, the control interfaces, the power management systems all had roots in military research that traced back through various developmental paths to programs like the Goliath. It's impossible to draw a direct line from the Goliath to modern remote-controlled civilian technology, but the conceptual influence was real. The idea that machines could be sent into dangerous environments as human surrogates, controlled from safe distances, performing tasks too risky for direct human involvement, that idea was pioneered by weapons like the Goliath. The fact that the military applications failed in the 1940s didn't invalidate the concept. It just meant the technology needed time to mature. The psychological impact of the Goliath on the soldiers who encountered it deserves deeper examination. For troops accustomed to facing human enemies, the Goliath represented something fundamentally different. An enemy without fear, without morale, without the human vulnerabilities that soldiers instinctively understood and exploited. You couldn't intimidate a Goliath. You couldn't suppress it with suppressive fire in the traditional sense, making it keep its head down while you maneuvered. It would keep coming with mechanical persistence until physically stopped, or until it reached detonation range. This created a specific kind of battlefield stress that was qualitatively different from facing human opponents. American combat stress reports from units that encountered Goliaths noted that soldiers found them particularly unnerving, even after learning how to counter them. The mechanical nature of the threat, the impersonal inevitability of the approaching explosive device, triggered anxiety responses different from those caused by conventional weapons. Some soldiers reported nightmares about Goliaths after encounters, dreams where the devices couldn't be stopped, where bullets had no effect, where the mechanical crawling just continued regardless of resistance. This psychological dimension of facing automated weapons was poorly understood in the 1940s. Military psychology was still a developing field, and the specific stresses of facing remote-controlled weapons hadn't been systematically studied. But the reports that do exist suggest that troops found Goliaths unsettling in ways that conventional weapons weren't. This psychological factor might partially explain why some German commanders continued using Goliaths despite their poor combat record. Even when the devices didn't reach their targets, even when they were disabled or destroyed before detonating, their mere presence created stress and consumed enemy attention. A German position with Goliaths might force attackers to be more cautious, to advance more slowly, to divert resources to watching for and countering the mechanical threat. In this sense, the Goliath functioned as psychological warfare even when it failed as a demolition tool. Whether this psychological benefit justified the resource investment is debatable. German commanders at the time had mixed opinions. Some valued the psychological effect. Others saw it as wishful thinking, an attempt to justify a weapon system that simply didn't work well enough to merit continued production. The story of specific Goliath units provides insight into how the weapon was actually employed at the tactical level. Panzer Pioneer Company 811, one of the first units equipped with Goliaths, served on the Eastern Front from mid-1942 through late 1944. Their unit history, compiled from war diaries and post-war interviews with survivors, shows a pattern common to most Goliath units. Initial enthusiasm about the new weapon, early combat uses with mixed results, gradual disillusionment as the weapon's limitations became apparent, eventual relegation of the Goliath to a secondary role while the unit focused on conventional engineering tasks. By late 1943, Company 8111 was using Goliaths primarily in situations where conventional demolition was too risky, but they no longer expected the devices to be decisive. They'd become just another tool, useful in specific circumstances, useless in others. The company's Goliath allocation was progressively reduced as attrition and combat losses weren't fully replaced. By early 1944, they had perhaps a dozen functional Goliaths, down from the 30 they'd received in 1942. By mid-1944, as the Eastern Front collapsed and German forces retreated westward, most of their remaining Goliaths were abandoned or destroyed to prevent capture. The survivors of Company 811 ended the war doing conventional combat engineering with conventional tools, the Goliath experiment a fading memory. Panzer Pioneer Company 315, serving in Italy, had a somewhat different experience. The mountainous Italian terrain seemed better suited to Goliath operations than the open steppes of Russia. Roads wound through narrow valleys where Allied forces had limited room to maneuver. Defensive positions could be prepared with clear lines of sight for Goliath operators. The company achieved several successful Goliath engagements against Allied forces in late 1943 and early 1944. They developed specialized tactics for mountain warfare, positioning Goliaths in concealed locations near roads, waiting for suitable targets, then launching quick attacks before Allied forces could react. One documented success involved destroying an American Sherman tank that was immobilized by a thrown track while climbing a steep section of road. The tank crew was working on repairs when a Goliath emerged from rocks beside the road, crawled up to the immobilized Sherman, and detonated beneath it. The tank was destroyed, the crew killed. From a German tactical perspective, this was an ideal Goliath engagement. But Company 315's successes were exceptions. Most of their Goliath attempts failed for the usual reasons: cables cut, vehicles stuck, operators unable to see targets clearly in the complex terrain, Allied countermeasures. By the time the Allies broke through the Gothic Line in 1944, Company 315 had largely abandoned Goliath operations, focusing instead on demolition work to slow the Allied advance, through conventional means, blowing bridges, cratering roads, mining approaches. The final months of the war saw the last significant Goliath deployments, and they were characterized by desperation rather than tactical sophistication. In early 1945, as Allied forces closed on Germany from both east and west, remaining Goliath stocks were issued to various units with little coordination or tactical planning. Some were used in the defense of the Rhine crossings, deployed to attack Allied bridgeheads. Most failed. Allied forces by 1945 were thoroughly familiar with Goliath countermeasures and destroyed them easily. A few were used in the defense of Berlin, the final battle of the European War. Soviet forces advancing into the city encountered occasional Goliaths in the rubble-choked streets. Soviet troops, veterans of years of combat, treated them as minor nuisances. Machine gun fire would disable them, or soldiers would simply avoid them, let them crawl past, then cut the cables trailing behind. There's a Soviet photograph from the Battle of Berlin showing a knocked-out Goliath in a street, its front armour penetrated by anti-tank rifle fire, Soviet soldiers casually walking past it as if it were just another piece of German wreckage, which, by April 1945, it essentially was. The very last Goliath combat use of World War II is difficult to definitively identify. Combat records from the final chaotic weeks are incomplete, but one candidate is an incident from April 28, 1945, in Berlin near the Reichstag. A German SS unit, defending against Soviet assault, deployed a Goliath towards Soviet infantry advancing through rubble. Soviet troops saw it, recognized it, and concentrated fire on the cables. The cables were severed, the Goliath stopped, and Soviet engineers later examined it. The explosive charge was removed and the vehicle was pushed aside. 2 days later, Berlin surrendered. If this was indeed the final Goliath combat use, it was appropriately symbolic. A weapon that had begun the war as an innovative experiment ended it as an ineffective curiosity, easily countered, quickly forgotten in the larger drama of Germany's collapse. Within weeks, Surviving Goliaths scattered across Europe were being collected by Allied forces, examined, catalogued, and mostly scrapped. A few were preserved for museums and technical study. The rest were destroyed, another failed weapon system consigned to history. Post-war German military engineers who had worked on the Goliath program were extensively interrogated by Allied intelligence. These interrogations, declassified decades later, reveal interesting perspectives on why the program continued despite its poor results. Several engineers noted that by 1943, cancelling the program was politically difficult. Resources had been invested, production facilities established, specialised units trained. Admitting the weapon was a failure would have meant admitting those resources were wasted. German military bureaucracy, like military bureaucracies everywhere, had momentum. Once a program was established, stopping it required overcoming institutional inertia. Additionally, there were occasional successes that kept hope alive. Every time a Goliath achieved a significant kill, every time one successfully destroyed a target, it reinforced the argument for continuing production. The engineers could point to these successes and argue that with more refinement, with better tactics, with improved models, the weapon could become truly effective. This pattern of occasional success justifying continued investment, despite overall poor performance, is common in military procurement. The Goliath wasn't unique in this respect. It was simply one of many weapon systems throughout history that consumed resources beyond their actual utility because institutional momentum and occasional successes sustained them. One engineer, interrogated in 1946, provided a particularly candid assessment. He stated that by mid-1944, everyone involved with the program knew the Goliath was not living up to expectations. But Germany was losing the war, resources were scarce, and stopping production would have freed up factory capacity that would just be assigned to produce something else, possibly something the engineer had no control over. There was a certain bureaucratic logic to continuing Goliath production, even when its effectiveness was questionable. The factory workers were trained, the supply chains were established, the production processes were debugged. Switching to a different weapon would require retooling, retraining, disruption. In a collapsing military situation where everything was chaotic, maintaining existing production, even of questionable weapons, had a certain desperate logic. This engineer's assessment might be self-serving, an attempt to justify his role in a failed program, but it rings true. The final year of the war saw Germany producing numerous weapons of questionable utility simply because stopping production was more difficult than continuing it. The ultimate question about the Goliath is whether it represents a failed weapon or a premature weapon. Failed implies the concept was fundamentally flawed. Premature implies the concept was sound, but the technology wasn't ready. The evidence suggests premature is more accurate. The mission the Goliath attempted, delivering explosives to targets by remote control, is valid. Modern military forces accomplish this mission routinely with drones, guided missiles, and remote-controlled vehicles. The Goliath failed because 1940s technology couldn't support the mission requirements. The cable control system was the only practical option at the time, but it was also a fatal vulnerability. Radio control would have solved many problems, but radio technology wasn't mature enough. The mechanical components, the engines, the tracks, the steering systems, these were adequate for the mission. The control system was the weak point, and there was no solution available with 1940s technology. If the Goliath had been developed 20 or 30 years later, when radio control technology was practical, when miniaturized electronics were available, when remote operation systems had matured, the outcome might have been very different. But in 1942, the technology simply wasn't ready for the mission. Modern military observers examining the Goliath through the lens of current technology often express surprise at how close the Germans came to creating an effective system with such primitive technology. The basic design was sound, the explosive payload was adequate, the mobility was reasonable for a small tracked vehicle. The vulnerabilities were inherent in the technological limitations of the era, not fundamental flaws in the concept. This assessment suggests the Goliath deserves recognition not as a failure, but as an ahead-of-its-time weapon that anticipated future developments by decades. The engineers who designed it weren't fools. They created the best solution possible with available technology. That the solution wasn't good enough for widespread success doesn't negate the engineering achievement. They built over 7,500 functional remote-controlled explosive delivery vehicles with 1940s technology. That's remarkable, even if the tactical results were disappointing. The Goliath's place in military history is secure, not because of what it accomplished in World War II, but because of what it represented for future warfare. It was one of the first attempts to remove humans from immediate combat danger by using remote-controlled machines. That concept would eventually revolutionize warfare, but not in the 1940s. The technology needed another 50 years to mature. When modern soldiers operate bomb disposal robots, when drone operators launch strikes from thousands of miles away, when autonomous weapon systems are debated by military ethicists, the conceptual lineage traces back through various developmental paths that include programs like the Goliath. The mechanical beetle that crawled across battlefields between 1942 and 1945, more often failing than succeeding, was an early step toward a future where machines would increasingly replace humans in dangerous military roles. The Goliath didn't succeed in its own time, but it pointed toward transformations that would reshape warfare in the decades to follow. That's its legacy. Not what it accomplished, but what it attempted. Not what it was, but what it would become.